Introduction to Neural Networks with Java, Class 11, Part 3. Welcome to Part 3. To predict the S&P 500, the neural network that we are presenting in this example program needs to have two input sets. We are feeding it historical data from the S&P 500 as well as the historical rate information for the prime interest rate. We need to be able to take these two data sets and combine them together to produce a training set that will allow the neural network to make an attempt to predict the S&P 500. These two data sets are somewhat different in terms of their level of granularity. The historical data for the S&P 500 contains samples that are taken on a daily basis, or at least days that the stock market is open in the United States. The prime interest rate data is different. It does not take a sample every single day. It simply shows when the prime interest rate has changed, what date it changed on, and what it changed to. So we need to take our data, our two data sets, and produce a training set that is the aggregate of both of these. We also need to decide what the granularity of our training data is going to be. It's going to match the S&P 500 daily values, but we need to stitch it together and find the prime interest rate on each of these days. In this part, we're going to look at how we actually bring this data all together and produce training sets for the neural network. We begin by looking at the structure of the neural network. The structure of the neural network is relatively simple. This structure can be changed by changing the configuration options that we discussed in the last class session. Inputs 1 through 10 are the percent moves in the S&P 500. Inputs 11 through 20 are moves in the prime interest rate. They both correspond to the preceding 10 locations in the time slices. Output 1 is the predicted movement for the S&P 500. These are all percentages. Because they are percentages, we need to use an activation function that supports both positive and negative numbers. The default sigmoidal activation function that the neural networks use is not applicable for this because it only accepts positive numbers. Therefore, we're going to use the hyperbolic tangent activation function as the activation function for this neural network. This will support the entire number range that we need. And here you see the method that is responsible for loading the S&P 500 data from the CSV file that was provided. Here we create a read_CSV class that is going to read the CSV file. This is a class that was provided by the book. It will loop over all of the lines in the CSV file and parse the data according to the headers. You can see that there's two headers that we're particularly interested in: the date that the transaction occurred in and the adjusted close. The adjusted close takes into account any splits that may have occurred. We have a financial sample that we create that holds the amount and the data, and we add this sample to the list. This sample is going to also hold the prime interest rate data that we will stitch to these values in a moment. We'll see how this is done. This loads the entire S&P 500 file to the actual data structure. And here we see the prime interest rate being loaded. This is a very similar procedure. We use a read_CSV class to parse the CSV file for the prime interest rates. We loop over all of the lines in the file and we read in headers. We are looking for the date and the prime rate for that specified date. We create an interest rate structure. The interest rate structure is separate from the financial sample that we saw in the previous slide. We are going to need to stitch these two together, and we will see this in the next slide. Here we add the rates to the rates list, and we continue looping over the entire file. We are only receiving rates for dates where the prime interest rate actually changed. This will have to be accounted for in the stitching process when we loop over all of the financial samples and attempt to assign the correct rate for each of those dates. At this point, the prime interest rate data and the S&P 500 data are in two separate lists. We need them to be in the same list so that we are able to properly process them when we want to create a training list. The training list needs to have data from both of these according to a date. The stitch interest rate stitches the interest rates to the correct financial sample data. We loop over all of the financial sample data classes and we obtain the rate for the date corresponding to it. The get prime rate simply looks through all of the interest rates and finds the correct interest rate that corresponds to the date that we passed in. This loop will continue through all of the samples that we have for the S&P 500, and it will fill in the needed rate field for each of these. Once this is done, we have a complete set of financial samples. Building the training data involves calling the get input data and get output data functions to retrieve actual data values from the S&P 500 and the prime interest rates. Here you see how we actually do this. We call the get input data method to create the input data. This is going to read the preceding 10 values from the S&P 500 as well as the interest rates. Here you see the loop. We loop over all of the interest rates and the S&P 500 values for this specified range. And we create a double array that has each of these values. We are using the percent for the S&P 500, the percent change, and we're using the real actual interest rate for the prime interest rate data. This is because the prime interest rate, if we have a high rate, that means something. Like if the interest rate is in the 15 percentile range, this is a very high prime interest rate. Whereas the stock data, the S&P 500, we don't know if the S&P 500 is in high range or not. It depends on where it was before. We look at large movements in the S&P 500, whereas we look at the overall location of the prime interest rate. Finally, we examine the get output data. It essentially retrieves the one value for the percent change in the S&P 500. This get output data is called both by the training set creation so that we can use it to create the ideal values, and we also call it again when we go to evaluate the neural network so that we can see on data that we haven't trained with what the actual output was, and we can see how far off the neural network was from the correct value. Here all we do is we create an array of doubles that is going to hold the financial samples that we want. We loop over the output size. In the standard case for this program it's 1, and we obtain a sample for each of the array elements, and we obtain the percentage, and we copy the percentage into the array that we are returning. This concludes part 3. In the next part, we're going to learn how the neural network is actually trained. We're going to implement a sort of hybrid training approach that makes use of both backpropagation and simulated annealing. We hope you will continue with part 4. Thank you. This course is based on our Introduction to Neural Network Programming books for Java and also Introduction to Neural Networks for C#. Available in both paperback and ebook format.